Okay, so in this lecture, we're going to begin to talk about polyprotic acid-base chemistry, which is certainly the most important focal point of this unit. So we'll start with a generic example of a diprotic acid, H2A. Right, there are two pKa's, or two equilibrium constants. Therefore, there are two ionizable protons in this compound. So the best way to approach any polyprotic problem is first to write out the equilibria of ionization, where the diprotic acid could ionize once and lose H plus. So that gives HA minus. HA minus could also ionize a second time to form a conjugate base A2 minus. So what is new is that we have this intermediate in between the fully acidic form H2A and the fully basic form A2 minus. We see that we have what's called an amphiprotic species. So that's a new and important vocabulary term. It means that this species can act as both an acid. If it acts as an acid, then that's going to involve the loss of H plus, or going from HA minus towards A2 minus. Additionally, it can act as a base, and a base would associate with a proton moving backwards to become the diprotic acid again.